Welcome to chemistry classes. In this video, we are going to discuss about carboxylic acid. Carboxylic acid. Okay, so here first we have to understand carboxylic acid functional group COOH. Carbon double bond oxygen single bond OH. This is the functional group of carboxylic acid. Carboxylic acid which contain number of carbon atom 12 to 18. Carboxylic acid which contain 12 carbon atom or from 12 to 18 carbon atom, such type of carboxylic acids are called fatty acid. Fatty acid means carboxylic acid which contain number of carbon atom 12 to 18, that is fatty acid. Okay. Also here we have to understand some nomenclature of carboxylic acid. Carboxylic acid. The name of the IUPAC name of carboxylic acid end with oic acid. The IUPAC name of carboxylic acid end with oic acid, ethanoic acid, propanoic acid, butanoic acid. Okay, so we can name carboxylic acid accordingly. Carboxylic acid which contain one carbon, it start with meth. IUPAC name methanoic acid. This is the IUPAC name of carboxylic acid which contain one carbon atom, methanoic acid, and here two carbon, ethanoic acid. Okay, so here HCOOH. This is the first member of carboxylic acid. Carboxylic acid which contain one carbon atom, that is HCOOH. And its common name formic acid. Common name of this carboxylic acid formic acid. IUPAC name methanoic acid. And here CH3COOH. This is the most common carboxylic acid. Acetic acid. Common name acetic acid. And IUPAC name ethanoic acid. Here two carbon. So ethanoic acid. Okay. And here, look here, this is dicarboxylic acid, here 2COOH. Okay, and here the common name of this carboxylic acid, oxalic acid. We have to use this acid for titration in chemistry practical. So this is the formula, oxalic acid. Remember, COOH. It is dicarboxylic acid. Okay, oxalic acid. And here two carbon, so ethane dioic acid, dioic acid, 2COOH. That's why we will say dioic acid, ethane dioic acid. This is the IUPAC name of oxalic acid. Clear? And here another one, benzene ring on the top, COOH, benzoic acid. Common name and IUPAC name of this acid, benzoic acid. Okay, and here benzene ring, here CH2COOH. Its common name phenyl acetic acid. We know here this is acetic acid and here it is phenyl acetic acid. Okay, and this is IUPAC name. You can give number like this, 1. This is second carbon. In second carbon there is phenyl functional group, 2-phenyl ethanoic acid, 2-phenyl ethanoic acid or phenyl acetic acid. This is the IUPAC name. Okay, 2-phenyl acetic acid. This is another one. This is also dicarboxylic acid and common name phthalic acid. Here P silent. Okay, phthalic acid. Okay, IUPAC name benzene 1,2 dicarboxylic acid. This is 1,2. Okay, so 1,2 dicarboxylic acid, benzene 1,2 dicarboxylic acid. You can check your textbook and use the table and find more carboxylic acid and check their IUPAC name and common name. Check your textbook. Okay, and check more example and find its common name and IUPAC name. I given here some example. Okay, next one we have to discuss here structure of carboxyl group. Structure of carboxyl group. Okay, we know in carboxylic acid COOH, carboxyl group. This is the functional group. Okay, and here this carbon in carboxyl group, carbon is comparatively less electropositive. Okay, here carbon is less electrophile compared to positively charged carbon in aldehyde and ketone. Similarly, we know aldehyde and ketone which contain carbon double bond oxygen, and we know here carbon act as electrophile C plus and oxygen act as nucleophile. Compared to aldehyde and ketone, carboxyl group or positively charged carbon in carboxylic acid less electrophile. Because of this type of resonance structures are possible. Because of the resonance structures possible, here positively charged carbon is less electrophile. Okay. And here next one we have to understand here methods of preparation of carboxylic acid. Different methods to prepare carboxylic acid. First one we have to understand from primary alcohol and aldehyde. Okay, so here primary alcohol or aldehyde after oxidation it will change to carboxylic acid, and here primary alcohol and aldehyde easily oxidize. Okay, even mild oxidizing agent needed to oxidize primary alcohol and aldehyde. After oxidation, primary alcohol and aldehyde, they will change to carboxylic acid. Example here RCH2OH. RCH2OH, we know it is primary alcohol. After oxidation, it will be carboxylic acid RCOOH. Okay, here to oxidize this we can use neutral potassium permanganate or acidic potassium permanganate or alkaline basic or alkaline KMnO4. Okay, so neutral potassium permanganate or acidic or alkaline potassium permanganate helps to oxidize primary alcohol to carboxylic acid or aldehyde to carboxylic acid. Also, we can use potassium dichromate, acidic or alkaline potassium dichromate, or we can use chromium oxide, CrO3. All this used as oxidizing agent. And here one example here, aldehyde after oxidation, aldehyde after oxidizing it form corresponding carboxylic acid. For example, CH3CHO after oxidation CH3COOH. Okay, so here preparation of aldehyde from primary alcohol and aldehyde. Clear? Okay, next method of preparation of benzoic acid. Here we are talking here method of preparation of aromatic carboxylic acid. Carboxylic acid which contain benzene ring. Okay, aromatic carboxylic acid. So here this method from method of preparation of carboxylic acid from methyl benzene or here propyl benzene. So generally we can say alkyl benzene. Alkyl benzene we can change to carboxylic acid. We can change to benzoic acid. Okay, we can change to benzoic acid in presence of oxidizing agent such as acidic or alkaline KMnO4. Okay, here to convert alkyl benzene to carboxylic acid, we can use oxidizing agent acidic or alkaline KMnO4 or chromium trioxide. Okay, here 3 oxygen chromium trioxide or acidic or alkaline KMnO4 used as oxidizing agent. So here methyl benzene and here look here methyl benzene, here CH3. This is the carbon. Here this carbon changed to carboxylic acid. Here this carbon directly attached to only one carbon atom. So that is primary carbon atom. Okay, primary carbon. Here this carbon, look here benzene ring, after benzene ring this is CH2. Finally that CH2 changes to COOH. Clear? So here this carbon atom directly attached to another carbon. So this is secondary carbon. So by this method, primary and secondary alkyl group change to carboxylic acid. Primary and secondary alkyl group can be oxidized and changed to carboxylic acid, but tertiary alkyl group or tertiary carbon atom do not oxidize by this method. Okay, so tertiary carbon atom, for example, look here, this is benzene ring, and here CH3, okay, and here one more CH3, imagine. So here this type of carbon do not oxidize in presence of oxidizing agent, okay, and here this is tertiary, and this type of primary and secondary alkyl group after oxidation it will change to carboxylic acid. So this is one method of preparation of aromatic carboxylic acid. We can prepare benzoic acid using methyl benzene or propyl benzene, okay, after oxidation. Here we will use oxidizing agent acidic or alkaline KMnO4 or chromium trioxide. Also remember, primary and secondary alkyl group will be oxidized, okay, and here tertiary, this type of tertiary alkyl group do not oxidize. Okay, next one we have to discuss here third method of preparation of carboxylic acid. Third method of preparation of carboxylic acid, here carboxylic acid prepared from nitriles and amide. Nitriles, we know nitriles mean the compound which contains CN, C triple bond N. This is nitrile. Nitriles after acidic hydrolysis or alkaline hydrolysis it will change to amide. Amide mean this is amide. Amide mean carbon double bond oxygen single bond NH2. Okay, so here two functional group. Okay, this together called amide. This is amide. Okay, carbon double bond oxygen single bond NH2. This is amide. Clear? So here this is nitriles. Nitriles after hydrolysis. H plus mean acidic hydrolysis or OH minus mean alkaline hydrolysis. H plus represent acidic hydrolysis, OH minus represent alkaline hydrolysis. Nitriles after acidic or alkaline hydrolysis it will change to amide. Amide again hydrolysis it will change to carboxylic acid. Amide after hydrolysis it will change to carboxylic acid, and this NH2 will change to NH3 or ammonium compound, ammonium salt. Okay, so here we discuss nitriles. Nitriles mean RCN. RCN after hydrolysis RCONH2 amide. RCONH2 again hydrolysis RCOOH. Okay, so look here, these are some example. This is another one amide. Here amide directly given CH3C double bond O NH2 amide. Amide after hydrolysis COOH plus NH3. Okay, this is aromatic amide. Okay, so this is after hydrolysis benzoic acid will be formed, aromatic carboxylic acid. Okay, so here this part it will change to C double bond oxygen OH, carboxylic acid, NH3 will be side product. So here nitriles or amide after acidic or alkaline hydrolysis it will be carboxylic acid. Okay. And here fourth method of preparation of carboxylic acid from Grignard reagent. We know Grignard reagent mean the general formula for Grignard reagent RMGX. X mean halogen, Cl, bromine, iodine. These are halogen X. Example for Grignard reagent CH3MgCl. Okay, so Grignard reagent we can change to carboxylic acid. So look here, Grignard reagent treated with carbon dioxide in presence of dry ether. Okay, Grignard reagent treating with carbon dioxide in presence of dry ether, it will change to intermediate compound, this type of intermediate compound. Okay, this is salt of acid. This is one salt of acid. Okay, and here this salt of acid, again acidic hydrolysis, it will change to carboxylic acid. So here Grignard reagent mean CH3MgCl or RMgX treated with carbon dioxide in presence of dry ether, it will change to salt of acid. This salt of acid, after acidic hydrolysis, it will change to carboxylic acid. Okay, this is one example. Here RMgX, carbon dioxide, dry ether, RC double bond O, OMgX. Okay, salt of carboxylic acid after hydrolysis, RC double bond O, OH, RC double bond O, OH. Okay, and the MgOH will be side product. Okay, so carboxylic acid will be the major product, and carboxylic acid, Grignard reagent, can be changed to carboxylic acid. Clear? Okay, next one, method of preparation of carboxylic acid. Fifth one, from acyl chloride and acid anhydride. Acyl chloride, we know acyl chloride means CH3COCl. Carbon double bond oxygen, single bond Cl. This is acyl chloride. This acyl chloride, after acidic hydrolysis or alkaline hydrolysis, they produce carboxylic acid, COOH. Acyl chloride, after acid hydrolysis or alkaline hydrolysis, they produce carboxylic acid. Here acyl chloride, after acidic hydrolysis, they produce carboxylic acid directly. Acidic hydrolysis, they produce carboxylic acid directly. But alkaline hydrolysis, first they form carboxylate ion, COO minus, carboxylate ion. This carboxylate ion, after acidic hydrolysis, they produce carboxylic acid. Okay, so here acyl chloride, after acidic hydrolysis, they produce carboxylic acid directly, and here alkaline hydrolysis, carboxylate ion form, carboxylate ion, further hydrolysis, they produce carboxylic acid. Okay, this is the most easiest way for production of carboxylic acid from acyl chloride compared to acidic and alkaline hydrolysis. Alkaline hydrolysis is more readily takes place. Here, alkaline hydrolysis. Clear? So here we discuss preparation of carboxylic acid from acyl chloride. Next one, preparation of carboxylic acid from acidic anhydride or acid anhydride. Acid anhydride mean, we know carboxylic acid, after removing water, they form acidic anhydride. C6H5 C6H5 double bond oxygen, single bond oxygen, single bond carbon. Okay, and here this is the functional group of acidic anhydride. This is the functional group of acidic anhydride. Okay, this acidic anhydride, after hydrolysis, they produce carboxylic acid. Okay, so look here, this is C6H5 C double bond oxygen, C double bond oxygen, C6H5. This one shortly you can write like this, C6H5. Look here, C6H5 coming 2 times. Also carbon double bond oxygen coming 2 times. So C6H5CO. CO mean carbon double bond oxygen twice and 1 oxygen. Okay, so also we can write acidic anhydride this way. Here C6H5 C double bond oxygen coming 2 times, that's here, and 1 oxygen. Okay, so this compound, after hydrolysis, they produce 2 molecules of C6H5 COOH. 2 molecules of benzoic acid formed. Look here, this is unsymmetrical acid anhydride, here C6H5 and here CH3. Here this is symmetrical and this is unsymmetrical. This is after hydrolysis. Look here, C6H5 COOH and here CH3COOH. Here both are C6H5, C6H5. So same carboxylic acid formed. Here a mixture of carboxylic acid formed. Here benzoic acid and acetic acid formed. C6H5COOH and CH3COOH. A mixture of carboxylic acid formed. Here benzoic acid. Okay, benzoic acid, and this is acetic acid. Two different type of carboxylic acid formed. So these are the method of preparation of carboxylic acid from acyl chloride. This is acyl chloride and this is acid anhydride. Clear? Next one, last method of preparation of carboxylic acid from ester. Here last method of preparation of carboxylic acid from ester. We know ester means the functional group carbon double bond oxygen single bond oxygen. This is ester linkage. This is ester linkage. Okay, ester. So ester after hydrolysis it produce alcohol and carboxylic acid. Okay, ester after hydrolysis it produce carboxylic acid and alcohol. Okay, and here this hydrolysis takes place in presence of dilute acid. So here acidic hydrolysis. Okay, acidic hydrolysis mean here this hydrolysis takes place in presence of dilute sulfuric acid or dilute hydrochloric acid. Here this ester will change to carboxylic acid. Ester can change to carboxylic acid in presence of acid, dilute acid, also dilute alkali. The hydrolysis which takes place in presence of acid, that is acidic hydrolysis. Okay, and acidic hydrolysis, after acidic hydrolysis they produce carboxylic acid directly, but alkaline hydrolysis ester first produce carboxylate ion. Okay, same like this. Here alkaline hydrolysis first produce carboxylate ion. Carboxylate ion further hydrolysis change to carboxylic acid. Similarly here ester after acidic hydrolysis. Ester after acidic hydrolysis we will represent H plus. Okay, hydrolysis in presence of dilute hydrochloric acid, dilute sulfuric acid, carboxylic acid formed directly. But alkaline hydrolysis ester first changed to carboxylate ion. Carboxylate ion further hydrolysis changed to carboxylic acid. Okay, carboxylate ion, see here carboxylate ion further hydrolysis changed to carboxylic acid. Example for this, look here, C6H5 C double bond oxygen C2H5. Ethyl benzoate. This is ester after acidic hydrolysis. This is acidic hydrolysis, benzoic acid and ethanol formed. Okay, and here another ester CH3CH2 C double bond oxygen C2H5. Ethyl butanoate after alkaline hydrolysis. Here ethanol, this part ethanol formed. Okay, ethanol formed, and here this part sodium butanoate. 1 2 3 4 carbon. Okay, so here also 1 2, here also 4 carbon. Okay, CH3 CH2 COONA, sodium butanoate. This sodium butanoate after acidic hydrolysis they produce butanol. 4 carbon, CH3 CH2 COOH. Okay, so alkaline hydrolysis first produce sodium salt of acid. This sodium salt of acid further hydrolysis produce carboxylic acid. Okay, here sodium salt of acid or generally we will say carboxylate ion. Carboxylate ion mean it is salt. Clear? So here we discuss preparation of carboxylic acid from acyl chloride and acid anhydride. Also we discuss ester can change to carboxylic acid. Ester after hydrolysis produce alcohol and carboxylic acid. Acidic hydrolysis produce carboxylic acid directly. Alkaline hydrolysis produce carboxylate ion or salt. it further hydrolysis produce carboxylic acid. Okay, next one, we have to discuss here physical properties of carboxylic acid. Okay, so here physical properties of carboxylic acid. Here first point we have to discuss here carboxylic acid, aliphatic carboxylic acid, aliphatic carboxylic acid, aromatic carboxylic acid. Aliphatic acid mean carboxylic acid, they have chain structure, not aromatic. There is no benzene ring. Okay, acetic acid, methanoic acid, this type of aliphatic acid, they are liquid state. They are liquid state. Aliphatic acid up to 9 carbon atom. Aliphatic carboxylic acid which contain carbon, number of carbon atom up to 9 carbon atom, they are liquid state. Higher carboxylic acid, they are wax like solid. So carboxylic acid up to 9 carbon atom, they are liquid state, and higher carboxylic acid mean carboxylic acid it contain more than 9 carbon atom, they are wax like solid, okay. And here carboxylic acid, they shows higher boiling point compared to aldehyde, compared to hydrocarbon, aldehyde, ketone. Here carboxylic acid shows higher boiling point, because here carboxylic acid, they form intermolecular hydrogen bond. This is one carboxylic acid, this is another carboxylic acid, and here this type of bond, these are hydrogen bond. Okay, electropositive hydrogen and electronegative oxygen, they form intermolecular hydrogen bond. Because of this intermolecular hydrogen bond, here carboxylic acid shows higher boiling point. Carboxylic acid, here lower carboxylic acid mean carboxylic acid which contain number of carbon atom 4. Carboxylic acid, here carboxylic acid, lower carboxylic acid mean carboxylic acid number of carbon atom 1 to 4, number of carbon atom methanoic acid, ethanoic acid, propanoic acid, butanoic acid. This type of carboxylic acid contain number of carbon atom 1 to 4. They are lower carboxylic acid and they are miscible in water. They dissolve in water because they make intermolecular hydrogen bond with the water molecule. Okay, and here aromatic carboxylic acids are insoluble in cold water. Aromatic carboxylic acid insoluble in cold water. Okay, but they are soluble in organic solvent, polar organic solvents such as benzene, chloroform, ether, alcohol. Okay, aromatic carboxylic acid mean benzoic acid, okay, ethyl benzoic acid. This type of carboxylic acid, aromatic carboxylic acid, they are not soluble in cold water, but they dissolve in polar organic solvent. Example benzene, chloroform, ether, alcohol. These are example for polar organic solvent. Clear? So here aromatic carboxylic acid dissolved here in this type of polar organic solvent. Clear? So these are the things we have to discuss in this video. Here in this video we discuss carboxylic acid, naming of carboxylic acid, structure of carboxylic acid, preparation of carboxylic acid. Also we discuss physical properties of carboxylic acid. Physical properties here, aliphatic carboxylic acid up to 9 carbon atom liquid state, higher carboxylic acid wax-like solid, they shows higher boiling point because of intermolecular hydrogen bond, and carboxylic acid up to 4 carbon atom, they miscible with water, and aromatic carboxylic acid do not dissolve in cold water but they dissolve in hot water. Also aromatic carboxylic acid dissolve polar organic solvent. Example for polar organic solvent benzene, chloroform, ether, alcohol. Okay, this type of solvent here, aromatic carboxylic acid will dissolve in this type of solvent, polar organic solvent. Clear? So next part, chemical reactions of carboxylic acid we will discuss next video. Okay, so thank you for watching this channel.